Hello, everyone, and thank you for joining us today and joining us on time. Let's uh, begin in a minute or so, and we'll let more people to join us. We'll begin in 1 minute. Thank you. Well, hello, everybody, again. My name is Boris. With us today is Yuval. Yuval is our CTO at K2View. A quick
Hello, everyone.
round of introductions. Yuval, a quick round of introductions. Yuval spent many years building products for enterprises and managing large teams of uh, very good developers, and Yuval is very good at that. He is also very interested in cutting edge technologies and has been following and working with LLMs, GenAI, the chain of thought, and other generative products and data products. So he has a lot of experience in doing that. My background is also in enterprise architectures. I've been working across industries, banking, telecom, insurance, and what interests me a lot, and I'm very excited about AI, and specifically how it changes our software development processes, and also how it influences and impacts the overall enterprise architectures. So with that, let's jump into today's session. We're gonna spend roughly 40-50 minutes on a presentation, and then have a little bit of time for questions and answers. So if questions come along the way, there is a tab on the bottom of your screen called questions. You can start thinking about that and posting them as soon as they arise. But in terms of agenda today, a couple of topics. First, we're going to try to set up an overall context for enterprise architecture and how agents, and specifically agentic AI, does influence those kinds of architectures. What are the trends? This is just to set up an overall context. We'll dive into enterprise data and what it really means to organize data for AI, make it AI ready. We'll spend a little bit of time on that, and we'll share with you our approaches, our experiences, our technology that worked for us for many years, and hopefully that will be useful. Then we'll jump into a demonstration. Demonstration will show us an example of a mock-up banking enterprise and how we would organize data and how we would expose it to agentic AI. So we hope that this is going to be insightful and interesting, and please make it interactive, post questions, and we'll try to answer them as we go along. So with that, let's jump into the presentation itself. I want to start by what works for me quite well is, first of all, at a very high level, assess what is our current state as is in terms of architecture and how we build applications, but also what is the future state. And I don't think there is much sort of disagreement on this today, that agentic AI is something that is up and coming, and we have to take it seriously, and we have to start getting ready for it. But if we look at the way applications are developed, again, nothing new here, but traditional applications are generally three-tier applications. We have databases, we have business logic, we have UI, and that's how users interact with the systems. As we move to the agentic stack, it's quite a bit different. Agents are delegating business logic to sort of a digital brain, if you will, which are all kinds of models, LLMs, neural networks, and so forth. So they really decide how the systems behave. Agentic systems, though, still have access to databases. Databases are sort of like a lifeblood, if you will, of the system, which enables them to make the decisions. But the approach is very different. So if in a traditional world, we actually are building the applications, we're developing software, right? We're programming them, where we're incorporating business logic. Agentic systems are very different in a way that we configure agents, right? We give them context, we give them intent, and then they, based on their digital understanding and brain, try to figure out what is a desired outcome, right? So the systems are very, very different, configurable versus programmed today. So that's one aspect of where we're going. Let me go to the next slide. try to illustrate another dimension, if you will, that as we're moving along this sort of advancements and evolution in a way where we're starting to use AI and agentic AI, there is an interesting trend, which again everybody agrees with. But in this case, this slide I like because McKinsey, one of the most trusted names in the industry, they do great analysis. So shows us that the value of agentic AI and agents and Gen AI is increasing quite significantly as the number of agents we actually utilize increases, right? And they sort of portray the state that currently there are very good use cases for Gen AI, which we're all familiar with, such as conversational AI, for example, or just generally increasing productivity, whether you're a business worker or you're a software developer, using AI models, using agents which complement your environment is very productive. But that productivity is really not earth-shattering, right? In order to be able to really improve the benefit side of the equation, as we go to, we're investing so much into data centers, training the models and so forth. The real promise, the real sort of exponential growth of value, if you will happen when we have multiple agents, many agents working on a certain task. So, for instance, a lot of people call this fleets of agents or multi-agent swarms. In this case, McKinsey calls it the digital agent factory, right? Again, meaning that multiple agents are working together on a particular task. So these are two interesting examples which are important in order for us to set up the context for what we're going to talk about now. Let's switch gears a little bit and put sort of like an architectural hat on and just think, abstract from everything and think if you and me would be sort of architects of this type of system, agentic system in an enterprise specifically. What would be the main building blocks, the moving parts, if you will, which are necessary to manage and operationalize very large number of agents, right? And we're not talking about several agents, where we are talking about hundreds and thousands, and sometimes people talk about millions of agents in an enterprise. So the components that we would start thinking about are, first of all, the platform, right? And we'll talk a little bit about what this implies. Then we need the models, right? Because models are really the brain of how these collections of agents interoperate with each other and collaborate with each other and create sort of like coherent networks of coordinated activities that result in a positive outcome. And the third very important component, and that's the one we're going to double click into today, is enterprise data. And why is data important? Well, data is really, if you'll think about an enterprise, right? Data is like capturing a state of an enterprise in a digital form, right? Whether you're talking about ledgers or employees or goods, services, or credit cards or accounts, data is sort of at each moment in time. Enterprise data represents the state of that enterprise, right? And if we want agents to be able to result in, produce some actions which are useful to us, that means that they have to have access to enterprise data, right? Enterprise data is a lifeblood of what agentic frameworks will be able to accomplish with us. And if that is the sort of outlook, let me point out something that sort of like frames this particular discussion, right? We've talked about three major components, right? The platform, which operationalizes how agents are managed in an enterprise. And platforms are, there are plenty of them, or there are few of them which exist today, but they're in the very early stages of maturity, if you will, right? But over time, you can see that the platforms will mature. They'll allow for you to develop agents within the platform, will bring your own agents, and they'll be able to control things like, how do agents onboard themselves, and how do you provide credentials and authenticate agents for instance, which ones are allowed to access what data, right? Or what is the sort of like audit log which follows an agent and shows us how the agent performs its actions. So all of that is a part of the platform. And platforms are not there yet. They're emerging, and very likely in a year or so, they'll reach the level of maturity where we'll be able to start using them. But it's something not under our control, right? It's third-party developers, vendors which develop these kinds of platforms are maturing, and their products are becoming more and more useful. The second element, the second building block of this ecosystem, AI models, are still evolving, right? They're fantastic today. People, very often we're also like feel this quote exponential growth in the capabilities. The latest models are amazing, but they're still not good enough to drive general purpose, sort of coherent behavior of multiple agents fulfilling certain tasks repeatably and reliably, right? They're still quite away from that. But again, we don't have any sort of control over that. That will take place by itself. Models will evolve. However, when it comes to enterprise data, this is something that we can really start acting on now, right? And for those of us who've been in the data integration space for a little while, we'll all understand that enterprise data is very messy, right? It's scattered across multiple systems. It has different semantics in different applications. It needs to be combined, and this gives us sort of an opportunity to pause for a minute. And agentic use of enterprise data is a unifying scenario, if you will, which allows us to approach enterprise data integration in a slightly different way than we did before. But the requirements are now universal, and they're quite clear. And that's what we'll talk about in the next few slides. Let's see. So let's double click into what are how would we organize data for enterprise data for agentic use? And a couple of very high level principles come to mind. The first one is separation of concerns. And that is quite intuitive and simple. And without really getting too deep into this, we would like agents to do what they do the best, which is reasoning and acting. And we would like to integrate the data, enterprise data, in such a way that it's optimally organized for use by agents, right? So this is a separation of concerns. We cannot rely on agents to do data integration for us, especially enterprise data integration. It's very complex. It's very precise. And data agents cannot self-organize the data for their own use. We have to pre-integrate the data. That's what we mean by separation of concerns. And a quick example.
Also very, you have to be very consistent about it. There's no room for statistical errors when you're talking about data integration, because then you have the wrong foundations to work on.
Yeah, so you actually bring up a great point that by definition, agents are probabilistic, right? So they introduce a certain amount of uncertain outcome, right? Data integration on the flip side should be very precise. You don't want to argue about the amount of money in your bank, right? This is something that people get very sensitive about. So in that sense, we as data integration architects and implementers have to be able to integrate the data in a way that is best laid out for the use by agents. So a very simple example: if we have some sort of online store, if you will, right, which has multiple backend systems, the data about a particular concept, like an order, for instance, right, is scattered across multiple systems, as we can see here. A little bit about the customers, a little bit about inventory that we have in the warehouse, a little bit about the shipment, which orders are really being delivered, which ones are not. So when we talk about the separation of concerns, we should be able to abstract the notion of where data actually physically lives in the backend systems to something that is easily consumable and organized for processing by an agent, right? So, for instance, an order, right? So that's the first, probably most important principle is organizing data in a way that is aligned and most optimally structured for the use by an agent. The second important aspect is semantics, right? And that's very important because the structure of the data is not sufficient to really understand the meaning of data, right? So in the past, JSON were good enough for us to do simple processing. Agents are different, right? They need the overall understanding of where a particular element, data element, fits into the overall scheme, into overall worldview that the model has. What has been very useful is a lot of industries for years have been developing standards. So for instance, in telecom TM Forum is a standard that defines ontologies, right? What is the universe that telco speaks, and what does every data element means in a bigger context of a telecom? Banking has a similar kind of standard called BIAN. Insurance has a court. So these are the world models, ontologies, which allow models and agents to figure out how to interpret the data. So semantics are very important, and they have to be coexistent with the data, right? And lastly, what's also very important is this notion of composability, meaning that we would like to break down data into small packages, which are then can be used by agentic layer to construct different kinds of outcomes, if you will. So in my mind, a good analogy here is Lego blocks, right? You can have a number of standard Lego blocks, but then based on different types of intents, you can build, you can build a bridge, you can build a skyscraper, you can build an animal, right? Out of all the same building blocks. In a very similar way, in the context of agentic layer, you want to give agents ability to work on packages of data and have outcomes which can be constructed in business processes, right, which are constructed in very different ways. So at a high level, these are the kinds of things that are very valuable as we think about, so how do we construct the data which is easily consumable by data agents, right? Data agents is the kinds of agents that you actually use to sort of construct the lowest layer of this pyramid, if you will, or the layer which accesses the data. So, but all of that was pretty theoretical, right? Interestingly enough, technology, so like there's an existing technology which we're going to mention now and we're going to dive into, which incorporates this kind of capabilities and principles that satisfy the way that we can organize the data for agents. And there are two technologies which come to mind, which we use a lot, but it's really more than a technology. It's more of like an architecture approach and the actual implementations that feed into this categories. And the first most important one is something called data products, right? So if you haven't heard of data products before, highly encourage you. It's very well documented. Every data vendor today is implementing data products in one fashion or another. And the concept of data products, it's very intuitive and simple, and then builds up on something that on a sort of architecture and software development side we've been using for many years. It's organizing, in this case, data. In the past, it's blocks of logic into objects, right? So data products are just like data objects. The important thing about them that they are reusable. And in the past, data integration approaches generally concentrated in sort of like a point-to-point integration. What data products do, they represent collections of data that is reusable by multiple business users, or in this case, by agents. Agents act as business users, and they can use the instances of data product to reason about things and act on that data. So the other very important components is something called MCP. MCP is not really technology; it's a protocol, it's a standard, but it allows data agents to access data products in a very straightforward manner, right? So it sort of like decouples the layer of data products from agents, and therefore agents can both discover, consume, and reason about data products by using MCP. So also another technology that is very useful. And those two technologies today form the architecture that really defines an approach for how to take enterprise data and organize it in a way that is easily consumable by the agentic layer. So with that, we can switch to K2View, right? And I wanted to talk about a product that we have, our approach, that really incorporates both data products and MCP and creates what we call agentic data product platform, right? It's a data platform for agents. And important to note here that data products are not specific to the way we use them. You can roughly think about enterprise data sort of like in three buckets, if you will. You can think about unstructured data in an enterprise, which is very useful, contracts, letters, and so forth, right? As an example, you can think about analytical data that lives in warehouses and data lakes, and you can think about operational data. These are all terms of trade. You know them very well. So where our product fits in, what we're specializing in is operational data products. And what it really means is we connect to the multiple systems of record in the back end. You can see it in this picture right here. And we reorganize the data, we aggregate it, we organize it in a way that is organized in operational data products, which are then in turn exposed through MCP servers and through APIs for the purpose of being used by data agents. So in this picture, we're showing like three probably most common data agents that exist today. These are agents for conversational AI provided by some of the leaders in the industry. And our product is organized in such a way that it allows us to expose enterprise data to any type of data agents that exist in an agentic environment. Right, so that's the backdrop. The question is then, so what is so unique about K2View approach? And a couple of things come to mind. These are at a very high level. So first of all, we have a lot of experience in working with the largest systems in the world, the most complex systems in the world. Examples of Customer 360 is a good example because it's very close in the way it's implemented and utilized to data products. But we have some of the largest Customer 360, Billing 360, Order 360 implementations that have been very successful across the largest companies. So that's very important, right? Real-time access at scale is something that agentic AI is really pretty much based on. The second very important element is cost, right? The fuel, if you will, of agentic processing is something we call a token, right? And what we do with data product architecture is allow the agentic layer really use tokens for what they were intended for, right? For really. Because we pre-integrate the data, very complex data, and give it to agentic layer in a form that is easily consumable, agents don't have to waste tokens on things which we already have done for them in a backend, which is very, very important. As you scale to thousands and millions of agents, this kind of, as we talked about, separation of concerns is critical. For one of the critical aspects is saving the cost of running those, or the cost of running those. And lastly, something we haven't really talked about, but in the context of agents is very critical, is the notion of security, right? Because we're talking about the data layer and data privacy, data security is supreme. At this point in time, we will not dive into this, but our platform presents a very unique, very powerful security model to data, which allows very tight control in terms of what agents can see, what they can access, what they can modify, and so forth. So security is another aspect of the platform, which is very powerful. So the last point before we dive into the demo is, so we've sort of like painted this picture that agentic AI is here. We have to start working with it. That the number of agents is going to be astronomical as we mature in this field. So how do we start, right? The three best practices that we use with our customers are quite simple. First of all, it's very important organizationally for an organization to have a strategy, right, which is agentic strategy or AI strategy of some kind. And most of the organization today in one way or another are looking into that, right? So that's the first important step, which is non-technical. The second very important step is to really zero in on architecture, right? Because what we're doing is truly the paradigm shift in how we're augmenting existing enterprise applications with new agentic layer. We need to select a path which relies on architecture rather than a specific technology. And that's what data products actually allows us to do. Data products is an architecture. It's independent of underlying technology. You can use warehousing in conjunction with something what K2View provides with operational data. You can use vector databases for non-structured data and present them as data products. So data product is architecture. It's very powerful. And the last point, which is also very key as we think about how do we start working with this new paradigm, is this notion of starting small and then expanding. In a software development, all of you know that we have a technique called minimal viable data product, right? And that allows us to sort of understand well what the requirements, what basic user requirements are, and starting building the processes and applications around that. Interestingly enough, because data products rely heavily on the same kind of techniques as a software development process, there is the notion of minimal viable data product, where you define, very often it's just a customer, right? Data product of a customer, and then start building. Start first of all making sure that the definition of the product is consistent with what users expect, whether it's business users or agents, and then starting expanding that particular data product instance as minimal viable product, but also expanding to other products as they become available. So that's the backdrop. We didn't go into a lot of detail, but hopefully that's useful in terms of setting up the context and what is the approach that worked for us, that worked for our customers in the context of defining what AI-ready data for an enterprise really means. With that, we'll move to Yuval, and Yuval will share with us how it actually looks like on Canvas and development environment and what it really means in practice. Yuval?
Thank you, Boris. So we're going to see how our platform supports data products, how MCP is built on top of that, and then we'll see a nice chat agent working on top of all of that. So we'll kind of go through the steps of how our projects look like with the data platform studio. Let me share my screen. So Boris, can you confirm that you're seeing it?
I'm confirming. I can see it.
Okay, cool. All right. So when we go into a project, we look at our first step is to create the data products needed out of whatever is available in the enterprise. So we start with the discovery process. The discovery process is just defining a source of data. Here it's the CCMS, credit card management system. The demo story here is that we're going into a bank and we want to create a customer data product. So the first step in every project we do is scanning the data sources. We have a very robust list of classifiers that look at data, crawl data, and really try to understand it. The list is quite long. Let me just go over it. But the discovery pipeline supports a lot of plugins. There can be plugins that use anything from a simple regular expression all the way to LLMs that really try to make sense of the data, statistical analysis, and of course it's expandable. So every organization can add their own classifiers that adhere to their conventions or the way they're laid out. Here I took a very small list. It's just a demo. We're looking at a very simplified environment. And once we do that, once we understand the sources, we have this versioned catalog. So we can look at the enterprise landscape over versions and multiple iterations. And the way it looks is just, in this case, it's just a bunch of tables in an Oracle database, but it can be documents, it can be web services, document stores, anything can be scanned. And we standardize it into this structured data. And you can see here that for every data point, there's it looks like tables. Again, it can be a document as well. We understand what is PII here, the personal identifying information. We understand the relations between the tables, that they can be declared relations, such as in a document or a foreign key in a database. They can also be based on statistical analysis, on query analysis. We look at every data source we can to create this structure. And the reason we want to do it is because when we want to create a data product, we want it to follow entities. You talked about it, Boris, that we really want to, when we look at data, we don't want to look at a bunch of tables. We want to look at something that makes sense to the LLM. And in this case, it's a customer, right? We want to have a chat regarding a specific customer. The backstory is a customer comes online and wants to talk to the bank and do some queries. And we want the LLM to only see the data that pertains to this specific customer. So we really need to understand the relations between all the tables in order to be able to create out of them a data product that follows these relations and really understands what a customer looks like. And this assures that we bring only the relevant data to the customer, so we don't confuse the LLM, and we also maintain security. The LLM only sees data that pertains to the particular customer that's currently logged in. So once we finish the discovery process, we have a really good understanding of our data sources. Our next step is to create a data product. Switch to the studio view here. See the studio right here. I already went ahead and created the data product in this case, just for brevity, but it can be as simple as looking at the data from the various sources and bringing the schema into the data product. So that's a very simplified approach, but there can be also extensible data mapping. And what we see here is all the data sources that belong to a customer across multiple systems. So it starts in this case with let me expand this. So it starts with the CRM. We started by taking data from the CRM, and from the CRM we jump to the loan system, or to the demand deposit account, or to the credit card system, which we'll be focused on in our demo. And since we understood in our catalog all the relations between the tables and those systems, we can kind of follow these relations, whether they're logical or physical relations. For sure, the cross-system relations are logical. We can follow them and create this view of a customer. And of course, this can be, in this simplified demo, it was 100% automatic. But of course, there can be manual intervention. We can also use an LLM to help us along and guide us in the creation of the data product. Every one of these tables reside in what we call a microdatabase. And this microdatabase represents a single business entity instance. So if we have 100 customers, we would have 100 of these microdatabase objects, each one representing one customer. And Boris, this is a key to our security paradigm, because it means when we bring this microdatabase into the scope of the LLM, it cannot see beyond that microdatabase. It can only see this one particular customer we're currently interested in.
Yuval, a quick question here on this. So who normally designs a data product? You're showing like a visual environment.
Yes.
It- Mhm.
So it can be anywhere. It really depends. In some organizations,
Mhm.
these are actually developers that are doing it. Most common is the data engineers or the data scientists in the organizations. In some cases, it can even be the business owner. Um, of course, depending on the complexity and the time on their hand. The system is relatively easy to manipulate and to work with.
Mhm.
Everything is very visual. So you have here the schema, but if I go in and I want to see how data is coming into the system, I can click what we call here population. And these are, very small ETL, very visual ETL building blocks that enable me to model my data movement. And here we took a very simple approach. We're just taking all the data from a certain database and putting it into our database. The system in the back end already follows all the relations. So as far as I'm concerned, I'm taking all the data from this table, but the system with its internal guardrails makes sure that we only take the data that belongs to the active instance we're looking at, the active customer. So I don't have to worry about that. And of course, I can add here any number of data manipulation objects. We have a lot of built-in ones. You can create your own. Developers can even expand it using Java and create additional flow building blocks.
So,
I can
still, let
sure.
me, if I can come back, because it's something that occurred to me, I think maybe quite interesting from your perspective. So normally you mentioned it's probably collaboration between developers, right? Data specialists and business experts who define the data product that we see in this other view, right? Which portrays the schemas. But how does it translate to the work with agents? How would you design it for agents?
Right. So the idea here, and I think you touched upon it as well in your deck, is you want to model it in a way that makes sense to agents and simplifies the work as much as possible beforehand, so the agent has access to data, fresh data, and doesn't need to deal with any integration. So if we look at the data here, and I'm just focusing on one customer number one. As I travel through the tables, I do a very simple query here. I just bring me all the data that belongs to this table, and behind the scenes, the system goes to the source and brings only the data just in time, only the data that belongs to this particular customer that's currently visible. So if you look at it from an agent perspective, we actually immensely simplified the work of accessing data. First, it looks as if it's one database, where in essence the data is spread across multiple databases. The agent doesn't need to correctly join the data in order to be able to see data that belongs to one customer. It can just look at the table and query everything in it, and it doesn't care about the sources. So it can just travel these very simple relations. We model them as very simple foreign keys. So as far as the agent is concerned, they're looking at a very, very simple database with foreign keys and very easy and straightforward to query. And in a sense, agents, LLMs are already born with the ability to very easily query a simple database.
Got it. Thank you.
Yeah. And we see here the just-in-time component of it. So every time I hit one of these tables, the agent behind this, the system behind the scenes calculates which data needs to be brought in. It can be incremental. It can bring the whole data set. Data can be pushed at us. This is a very robust ETL solution, but it's built around the business entity. So what makes our platform special is this idea that data revolves around the business entity and not a large list of disjointed data sets. And this is what makes the agent's life much easier. Our platform also comes, of course, with a lot of built-in agents that allow us to very easily compose agentic workflows with this data, and of course assemble them and call them from other agents outside the platform. But building this data product around the business entity with the guardrails of looking at the entity instance, this is the first building block of our agentic approach. The next step after that is, once we have it, for years customers have been using this platform for any number of cases, and of course we have APIs to query the data directly, and JDBC adapters, and there's and CDC, and there's a lot of integration patterns on top of our systems. But right now we're focusing on the agentic frameworks, and here is where MCP comes into play. So the minute we create a data product, we automatically expose it as an MCP server. And here we see an example. So this is the same project. I'm looking at the same MCP demo I'm showing here, just using its using MCP inspector to see the MCP structure. MCP is built out of resources, prompts, and tools. Those are the three important ones. There are a few more here we're not going to go into today. And basically different MCP clients use MCP servers a bit differently. So we modeled different approaches. So we can show our data products as resources, so the agent can really understand the metadata, and query tools to query the data. So say I have here a bunch of I'm just imitating what an agent would do. Let's say it wants the list of credit cards. So it will understand, it will list the tables, look at this description here, understand that this is my list of credit cards. It really knows SQL well, so it will do select star from, and it will run the tool, and it will receive the list of credit cards that belong to this particular user. Where is the user set? It's set here in the MCP URL. So if we see we're accessing MCP URL, customer bank, number one. So our MCP server is already exposing a single customer, and this customer is only available to it's the only customer that's available through this MCP server, and our agents can walk between MCP servers and look at different customers as the need arise. So once this MCP server is in place, then we can look at how it works. So and here is just our little playground for activating agents. And we have our agent that does a business analysis of can answer business questions around our data product. And I will ask it to list my credit cards and my balance. So here I have 2 credit cards. And LLMs are pretty smart. So if I ask how did I get to 2000, it will probably understand I'm talking about my Visa one. I can open here a trace behind the scenes, and I can see how the agents interact with the data. So they're taking the goals, what the user entered. It uses the LLM response. There's the context of the data product, and it uses all of these to create a response. The system can have generic agents. We can also tailor specific agents. And of course, this is all accessible to external agents directly with our MCP server. This is how it got here. We can also link it with tools. So we can also, in this case, can you recommend a better credit card? This will show our ability to link additional tools to the data product. So we're kind of expanding the idea of a data product to take tools and bind them together with the data product. In this case, we added the ability to look at other credit cards or look at other knowledge base and other capabilities that this demo bank has in order to expand the data product the agents interact with and to even perform actions. So I can say, please raise my limit to 7,000 on both cards. And of course, there's a whole process this requires. But since we added a tool to this data product that allows the credit card agent to do it, it was able to take the goal and through looking at the data and getting the credit score and calling the correct tool to update the credit card limit, it was able to update my limit. So and this leverages our ability to expand the data product with additional tools and make them part of the same MCP server.
Yuval, just to make sure I understood. Yeah, makes sense. What you are showing now is sort of an example of an agent, right?
Yeah.
Once we define a data product in our tooling, then the data product is exposed as MCP, and this is the environment to just test and visualize how that particular data product behaves.
Exactly right. And of course, the agents can be our data agents and used with additional agents on top of them. We also enable creating agents within our platform. But the basis of all that is the MCP server built on top of a strong foundation of a data product that represents this entity, both from, I would say, a security standpoint, where it only looks at the data product and instance, and with the robustness of multiple tables and choosing the correct table. Allowing the agent the freedom to move and traverse the data without being bounded to a specific, very small number of APIs.
Understood.
So that's my demo.
Can I? Well, I have many of questions. One is from myself, and then the audience gave us a couple of great questions as well. The first question is whether this data product feeding agents, is it something that at K2View we have experience with actual deployments and customers that you know of?
So yes, of course. We have actually now it's 3. It used to be 2 a couple of weeks ago, but now it's 3 customers who are actually deploying agents in production. It's still a bit early days in the sense that they're not exposed, as you saw here, directly to the end user. It's more of an assistant inside the organization, but it allows their representatives to really easily get a synopsis of the business entity and also quickly ask questions, perform actions, and really expedite their support initiatives and also batch activities across the organization. So very, very promising initial results.
So this sounds like it's a conversational pattern, right? So it's something that people use for. Got it.
Yes.
Got it. So
yes.
Yeah, it's a very common scenario. Well, we have a couple of great questions. Let me start with the first one. So you've shown how K2View environment can build data products from structured data. Is it possible to build them from unstructured data?
So yes, definitely. We do 2 things here. First, we have the capability to work with the standard vector database. We also have one embedded in the product, but we can use embedding from other sources, and we have a very tight control over context engineering in order to bring just the right context. We've also added vector databases to the business entity. So here we saw a completely relational model, some of it based on a document, some of it based on a document store, some of it based on tables, but the end result is a relational virtual database. We also have the capabilities to create model embeddings and a vector table per business entity. So we can see specific documents the customer signed, specific conversations, CRM support, etc. This capability is built into the product.
Thank you very much. Before we go to the next question, let me just remind everybody that there are certain controls that you have in your environment, that you can download white paper, you can download a blog, and also if you're interested in sort of a custom demo specific to your use to the kind of application and enterprises you're running with, we'll be more than happy to arrange for that. Just mention it in the questions, and we'll get back to you. With that, the next question is here: how does K2View ensure real-time response with up-to-date data? I think you've mentioned something about keeping data fresh. How does it work, or more, what is the outcome of this?
So the entity approach, the fact that we're looking at specific entities and not at entire tables, gives us a very unique opportunity to bring data on a very tight scale. So when we want to move data from a source to our system to make it available to the LLM, we don't need to bring everything in a nightly batch. We can bring just the data that belongs to this customer. And the reason is because we modeled what is a customer beforehand using our catalog and our automation tools. So this allows us to capture data just in time and bring a very small amount of data. If you compare us to standard ETL workflows that work overnight and bring over tons of data, we react, in sub-seconds because we only need the data that belongs to that one customer. We also have the capability to ingest data that is pushed on us and associate it automatically to the right customer, again, because we have this structure that really models how a customer is modeled across these very complex source databases. We can very quickly associate an incoming message to the right entity and make sure that it's fresh and up to date. The end result is usually sub-second fresh data across all the entities that are currently in action, right? And it's, at any particular moment, you're not looking at the entire list of entities. You're looking at maybe a few hundreds or thousand entities, and they're the ones that need to be fresh.
Got it. It sounds, just to refine, make sure I understood it correctly, it sounds like you described event streaming architectures, yet another way that we can sort of maintain the freshness of data, right? That's architecture, which is very popular in modern enterprise. So we would feed into that environment very nicely. Got it. So we have time for the last question, and I think we need to wrap up. Very good question here. Enterprise data is highly sensitive and contains private customer information and other confidential assets. How does entity-based data product approach ensures data security and privacy?
Yeah. So
while working with data agents specifically,
yes,
right?
Yes, of course. So we touched on the basics, which is just the fact that you're not allowing the agent to physically go beyond the entity gate, just by the mechanics of our MCP server. Even if the agent got it wrong and produced a bad query, they're still confined within the business entity. So I think that's our most powerful approach, and it's ingrained right into the heart of our technology. We also have supporting mechanisms around masking of PII data. If you notice, during the catalog discovery, we tagged PII columns, and this allows us to mask them according to the privileges of the system access. So if you have very strong system privileges, you will see the actual value. But if the agent comes in, they will see a masked value. And we can mask the values that are PII, and we can do it in a very consistent manner. So it will be the same across the entire business entity. And again, it comes to the power of modeling the business entity up front. It allows us also to create consistent masking across the business entity. And the masking can also be bidirectional. So, for instance, one of the very common ways it's used is mask the data before sending it to an LLM. So the LLM does not have access to PII data. And on the way back, reverse the masking, so the answer would be personalized to the user reading the answer.
Great. So I think we need to wrap up. There's actually just a question has been posted that whether it will be possible to get a transcript, because some of the answers in a demo went pretty fast, and I think it will be. So I think if you registered with us, then we'll be able to send you the transcript and probably the recording. So we'll have to wrap this up, but before we do, let me just share this slide with us in a summary, just so something is sort of like registered as like what we were trying to explain and dive into. So the points are quite simple. Where we've talked about the fact that agents are coming, and it's a good time to start preparing for it. And one of the things we can really start working with now is enterprise data. It's a never-ending journey. Even if we start now, it's unlikely we're going to finish it at some point in time. But like you say, with agents, like with any other software system, garbage in, garbage out. So in order for agents to be useful, you need to organize data in such a way that it makes sense to the models. And there is an architecture which embraces that in a very powerful way, which is data products, right? So if you haven't heard about those, please look into them. And this is front and center for us in terms of how our product is being used by our multiple customers. So we'll be more than happy to give you any kind of information about the product, our experiences, and we would love to hear from you. What's we call the tell us your story, right? What is your enterprise? What are the data integration problems, the challenges that you have? What are the opportunities? We would love to work with you, and please let us know. And one more time, thank you for joining us, and I hope that this conversation was useful. Thank you.
Thank you very much.